that we talked about was being able to analyze databases. And if I go into here, and this is also in the cloud here, I can see this is my database view. So I can see I've got a bunch of databases here. I can see throughput, and this is per application. So I can break this down and say, okay, just show me my Spring shop. And if I do that, then it'll just focus on Spring.
So you can see the effect of each application in the database.
Absolutely.
ColdFusion Alive, the podcast for the ColdFusion community. Discover practices, tools, techniques, tips and trends for modern ColdFusion development. Brought to you by TerraTech, the ColdFusion experts. Develop, secure, optimize. Here is your host, the founder of TerraTech, Michaela Light.
Welcome back to the show. I'm here with David Tattersall from Integral, and we're going to be talking about the amazing new features in FusionReactor 9 for making your ColdFusion apps run fast and not have crashes. Or if they do have slowdowns or crashes, you can diagnose quickly what's going on. And there's a lot of new features in version 9. So we'll get into that in the episode, and we'll do some demos. For those of you on video, you'll be able to see the demo. For those listening on audio, we'll walk through the cool stuff that you're seeing. And if you don't know David, he has been in the ColdFusion world forever. I don't forget what year you started in ColdFusion, but I remember seeing you at some early CF United conferences. And 1997. Wow.
Yeah, or actually the end of 96, I think it was. So
wow.
it was CF2, and we were an Aware partner, and we were a Macromedia partner, and now we're an Adobe partner. So
excellent.
We've been around for the long haul.
You have. And FusionReactor is used on 30,000 production servers. So if you're not using it, we certainly use it at TerraTech. Recommend you check it out. They have a free 14-day trial. You can try it out. And they have some low-price developer versions, or they have enterprise versions and all versions in between. So welcome, David.
Thank you. Thanks for having me.
Yeah. So for those few people who've never heard of FusionReactor, maybe you should explain what the heck it is.
What the heck is FusionReactor? So FusionReactor is an application performance monitor. So monitors essentially do two things. They measure stuff and they alert you if something's going wrong. So with measurements, we're talking about telemetry. So it measures things like CPU, it measures memory, it measures transaction throughput, it measures what you're doing on the database. And if it detects that something's gone wrong, then it can alert you. And it can also help you to pinpoint where the problem is. And it does that in a number of different ways through analyzing the data, so the metrics and the telemetry. It also does it by automatic error detection. So if it detects that some error has occurred, it will pinpoint that error for you. And you can also do things like production debugging. So you can actually go into your code, set breakpoints or set trace points to look at variables, and actually analyze your code as it's executing. So a whole range of capabilities. And we've also got some new stuff that we've just released, and we're just releasing right now, but I think I'll go through that in the demo.
Yeah, so maybe it makes sense to look at your mission slide, because I think that relates to what you were talking about.
So what I was going to talk about today.
This is what we're going to be covering in the whole interview, right? Mission, how applications have changed and how that affects monitoring with modern ColdFusion. Problems developers have with monitoring, how FusionReactor is different, your new unified observation platform where it can slurp in logs and other cool stuff. I'll go into detail on that because that's one of the new features, stability issues. And revealing what's coming out in FusionReactor 10 whenever that comes out. We don't have an exact date, folks, but I hear it could be next year sometime.
Could be coming soon, but
Yes.
we're releasing things all the time. So
Yes.
usually at sort of, I'd say 4 to 6 week intervals, we are releasing.
Oh,
so whether
you're a true SaaS.
we're a true SaaS, yeah. We're
Yes.
building, deploying all the time. So
Excellent.
yeah. Okay,
All
so
right.
what's the mission? Basically, to help developers gain better insight and transparency into their apps and speed up the task of finding issues. So, we talked before about, what's FusionReactor all about? Really, it's about helping you to find problems. And, that problem may be related to resources, it may be related to your code, it may be related to a database, all kinds of different reasons. But the whole objective of Reactor is to speed up that process, to help you. And we think we do that around about 5 times faster if you're using FusionReactor than if you were just trying to dig through the application directly.
I would say sometimes it's infinitely faster because when I talk to ColdFusion developers, sometimes they just totally can't figure out why their application is crashing or slow. So
yeah, I mean, we sorry, go ahead.
And the other thing I would say is the way we use it, we like it to proactively head off having the problems in the first place. If we have an alert set up that the CPU is getting high, we'll go dig into the application for our client and, hey, what's going on here? And so they don't even have the crash happen in the first place. So,
right, yeah, that's also a capability of Reactor. We call it crash protection. So that was it was actually one of the first capabilities that we built into the product. The whole idea was that as we're monitoring what's going on, if we do detect that there's a problem occurring, we can try and take action to remediate that problem. So, for example, if we see that you've got a long-running request, and that request is maybe it's blocking other requests or it's eating up resource, we can actually go ahead and try and kill that request. So this is all configurable, and normally you don't start off, by configuring it to kill. You normally configure it to email you with the details. So we'd email out the transaction details together with a complete stack dump. So all the different threads, we perform stack trace on all the different threads and send that out in an email, which very often can help you to pinpoint the problem. But FusionReactor can also take corrective action.
that is great. Yeah, I got a bit nervous when you said it's going to kill threads. It's almost like you're in a Godfather movie.
We only do it when we can. So
okay.
Obviously you might think, oh my God, killing a thread, that sounds
drastic.
dangerous. And in some cases it could be. I mean, you could, in certain cases, if you kill the thread, you could destabilize the JVM. But we check beforehand, and we would only allow you to kill a thread if it's okay. So yeah, it's not sort of FusionReactor kills all threads. That's not the case. But if we detect that we can help you and you've configured it to attempt that, then we would take that action. You can also configure it to, say, for example, queue threads. So if you were being overloaded by threads and you weren't able to serve those threads, then we can also detect that and we can buffer them. So that's, again, the whole concept of this is, are we able to do something which enables you to, keep stability of your application? That's really what that's all about. Okay, so a few highlights. Reactor's been around a while, since 2005. We've had well over 5,000 customers, around 35,000 production servers running Reactor. With the global market leader for CF, of course, for Adobe Server monitoring. But we've also got many customers who just use FusionReactor for monitoring Java applications. And we hope in the future that we'll have customers monitoring all kinds of different tech. But I'll come to that in a moment. We're also very proud, the logos that you see there, the G2 logos.
Who is G2?
So
G2,
for those who don't know, G2 it's a review site, and G2 is the review site. It's I believe it's the biggest in the world. They review everything. So any type of software product that you can imagine, G2 will review it. So if you've not heard of it, g2.com. And we've received a number of awards this year. We're actually around about fourth in the world for monitoring. So if you go and look, they've got a category for application performance monitoring. And last time I looked, which was I think last week or something, we were number 4 in the world for APM. And this is out of about, I think there's about 220, 225 different monitoring products. So something we're very, very proud of. We really do get great feedback from our customers for FusionReactor. So yeah, very, very proud of that.
Cool. Well, let's have a look how software development's changed in ColdFusion in the last few years.
Right. Yeah.
How that affects performance monitoring.
Yeah. So, I mean, in general, software development, I think, has changed full stop. You know, if you think of the good old days, especially with CF, you know, everybody had the pet server. And that's changing. You know, companies are moving to the cloud. They're moving to Docker containers or Kubernetes, and with the advent of ColdFusion 21, Adobe introduced support for microservices and even lambdas. So, you know, the Adobe's ColdFusion world is changing. And as that change has taken place, there's essentially been a shift in observability to be able to support the measurement and to support monitoring in these new environments. And sort of what came out of that is this concept of metrics, logs, and traces. These are the so-called the 3 pillars of observability. And where things are going in the future is more towards AI ops, so AI operations, and machine learning. So the future of monitoring really is going to be going into automation, where, you know, people are no longer sort of, you know, struggling, going through logs, trying to figure things out, but actually analyzing that data and making informed decisions based on what the machine learning algorithms are actually able to analyze. And I'll be able to demonstrate some of this to you as part of the demo.
Very cool. We'll talk more about the impacts of AI on performance monitoring later in the show. But you know, I think there is a move to more modern development practices. Not everyone does it. There's plenty of monolith apps still out there. So absolutely, just to reassure people, if you have spaghetti or some other rude name for your code because you inherited it from someone else, probably, you know, FusionReactor still lets you monitor that.
Absolutely, that's not going away. And you know, not everybody wants to go to cloud. Not everybody's able to go to cloud. So
well, yeah, not right. It may not make sense for their use case, or they may have concerns around cloud, particularly as AWS has gone down quite a few times over the past few years. So that's where that multi-cloud maybe comes in handy. Anyway, let's have a look at how other ways
carry
developers.
on. Yeah,
yes,
so
developers
those
have trouble with this.
Those damn developers, they're having to push huge stones around so that they don't have it easy. And why don't they have it easy? Well, 32% of developers who were surveyed told us that they spend at least 2.5 days to isolate production problems. And very often when I'm talking to people, I'll ask them, does that number fit? And very, very, very often it does. Some people say, yeah, sometimes it takes us a week or a couple of weeks. Sometimes it goes faster. But I think on average, 2.5 days is a good sort of value. We got this information from there was a D-Zone performance survey where we got this, and from that 2.5 days, the majority of time, so around about 75% of that time, is spent on this MTTK, which is this so-called mean time to know. And that's the portion of time where you're actually figuring out why you've got a problem. So usually it's pretty quick to know, oh, something's wrong, something might crash, or, customer might say, hey, you've got a problem here. And very often the fix is pretty quick. Once you've identified what it is, once you know what the problem is, you can usually fix it and deploy it pretty quickly. But the majority of time is really focused on this mean time to know, and that's the area that FusionReactor addresses. That's why we can really shorten, this whole sort of end-to-end time of being able to identify a problem, fix it, deploy it. That's sort of the total time, and that's really what we focus on reducing. And then, so the last statement, though, 94% of developers still use logs to identify errors in production. And that's, I think, pretty amazing. When I was developing, and this is back in the Stone Age, we were also using logs to identify errors in production, and not a lot has changed.
This podcast is brought to you by TerraTech, the ColdFusion experts. Develop, secure, optimize. Get detailed show notes on today's episode and your free CF Alive Modern ColdFusion Guide at terratech.com. That is TERATECH.com. And now back to today's show.
You'll be telling the Yorkshireman for Yorkshireman when I was a lad story next,
Well, I'd be careful, steady. I'm from Lancashire. So,
yes, so we have to be careful with Yorkshireman stories.
I know.
For those not aware, those are two warring
warring states back sort of 600 years ago. Yeah, but for a southerner, anywhere north of Watford Gap is, you don't really know about. I guess they're all northerners up there.
Yes. But the amazing thing is a lot of people still use logs because they don't know to do any better, and FusionReactor makes it really easy to pin things down. And I think I think you're absolutely right, David, that once you can see the lines of code or the database statements that are causing the problem, it's usually moderately straightforward to fix it. But the problem is sometimes these memory problems, they start off somewhere and the actual original cause is not always immediately obvious without a tool like this.
Absolutely, yeah. It's very often hidden in the details, or it's a collection of things. Sometimes you'll look at something and you'll think, oh, why is this transaction slowing down? It turns out it's some database that's calling, or it's some remote call that's going out to some socket or some other service, and that service is having a problem. And it's not even inside your code. But the trick to this is having the insight and the depth, so that you've got all the information at your fingertips, and that's really what Reactor's all about.
Yeah, I mean, just to clarify, the problem with looking at logs is there's so many entries in logs and it's like finding a needle in a haystack, whereas FusionReactor will, surface all the needles to the top, so you can just look at the needles and not all the straw.
Right. Yeah, that's what we do. And also and I'll demonstrate that as well, with FusionReactor 9. A big part of FusionReactor 9 was about integrating logs. So FusionReactor actually was always, we always captured logs. So we captured logs from all the telemetry that we instrument, so the metrics, everything goes into logs. So FusionReactor was, we always created logs, but we didn't really have the capability to ingest logs and then to link those logs to your transactions or to other to other metrics. And that's what changed with FusionReactor 9 as part of this whole unified observability platform that I'll come to in a moment. That was really part of the big change. So I'll show you that and demonstrate it very soon.
Yeah, let's have a look at what's in FusionReactor then.
Yeah, so real quick, what's Reactor deliver? Basically, it's developer-focused observability. So FusionReactor is really, very much a developer or DevOps-focused tool. We combine these three pillars of observability, so metrics, logs, and traces, together with very detailed profiling, debugging, and automatic error detection. So you can sort of think of it that we're watching everything, but at the same time, we're providing developer-focused capabilities like profiling. And by profiling, I mean code profiling or memory profiling, CPU profiling, plus the debugging and the auto error detection. So,
I mean, the way I think about it, for a lot of developers, the ColdFusion engine, whether you're using Lucy or Adobe, is a bit of a black box. Your code goes into it. Hopefully it runs. Sometimes it goes slow and you don't know quite why. And what FusionReactor is, it kind of like is an X-ray machine that lets you see inside the important problems going on inside ColdFusion.
Exactly. That's what it's funny that you say that, because very often when we're talking to people who downloaded the products, or I guess new customers, and they ask us what does it do, we sort of say it's like X-ray vision. It's X-ray vision for applications. So it shows you exactly what's going on and why things are occurring. So that's interesting that you picked that analogy.
Very cool.
Okay, so unified observability. What's this all about? So what we've been doing for about the last 18-19 months now is we've been re-architecting FusionReactor. So the 9 release was the culmination of those changes, and we re-architected the whole platform. So what we've done is we've embraced open source software in the form of Prometheus and components from the Cloud Native Computing Foundation, so CNCF. And we're using Prometheus or Cortex to capture metrics. We're using a tool called Loki to consume logs and process and index logs. And we're using a component called Tempo to manage the traces. And we've put all this together with a new user interface. That user interface is based on Grafana. So there may be people out there who are already using Grafana, but that will enable us as well to be able to offer the possibility that you can integrate your own Grafana dashboards into FusionReactor. So it really will become sort of a single pane of glass. And we're also doing that in conjunction, or these changes enable us to have hundreds and potentially in the future thousands of integrations by opening up this open source platform. And what we're also doing at the same time is we're embracing something called open telemetry, or OTel as it's known. And OTel will provide a number of agents for us so that we can actually support other languages. So right now, we've got our agents, if you like. If you go and download FusionReactor, you get the FusionReactor agents. And that FusionReactor agent is a Java agent. That's essentially what it is. And of course, it supports ColdFusion. But with the integration of OTel and support of OTel, that will enable us to also support other tech like .NET or C++ or Node or Python. So there's a lot of changes there that are going to be opening up, because we also see that ColdFusion's great, and we love ColdFusion, but what we're seeing is that some customers, they're saying, oh yeah, I'm using CF to do this, but on my front end I've got some Node. So they're combining tech. And we don't want people to, if obviously that's people's decisions if they want to do that. But from a monitoring perspective, we don't want to hold you back. If you're choosing different technologies, we want to be able to support you with that and give you sort of a unified observability platform. So you're going to be able to see all this information, whether it be metrics, logs, and traces, also infrastructure related telemetry. I'll show that to you as well, plus other technologies. So it's really, we're really sort of creating, if you like, sort of an umbrella platform here so that you can get insight right across your whole solution architecture.
Very cool. So just for people listening, just to clarify, metrics is things like the CPU use, memory use, other things that you can get from the server. They're kind of their healthiness. The logs is more of an historical thing. Here are events that happened, either they're errors or they're just a page was accessed, or, there's probably about 10 different log files you can turn on if you want to for ColdFusion. But it's all historic, but you could suck that in and correlate it with events that were happening. And then traces are where you insert, some call into the code to say, hey, this is going on, and tell me, how it's performing. Is that about right, or have I misunderstood?
It's sort of about right. A trace, really, a trace is a transaction. So whenever you do something, if you call a ColdFusion page or got some database transaction, that's what we call a trace. And
okay.
I'll show you
it's
that.
An event. Okay. Well, we'll look at that in the demo.
We'll look at that in the demo, yeah. But you'll see.
Right, but it's an important event occurring in your app that possibly could cause a slow up.
Exactly. Yeah, that's a trace, and traces have got the components that make up a trace are called spans. So if you think of some transaction, you might have a bunch of database calls. You might be calling out to some service. You might be, I don't know, calling to some Java components or something. Might be calling out to Node to render something. And all those things make up the trace, but each individual component of that is what's called a span. And you'll see that. I'll show you that in the demo.
Cool.
Okay, so without further ado, I've got a few things that I was going to go through. Basically, we're going to sort of take a look at how we can identify some performance and stability issues. And these are common sorts of problems that you might be faced with. So you might have resource bottlenecks, maybe due to some socket I/O or a caching issue. And we can analyze that using metrics and using the built-in profiling capability. Then you may have sort of external applications, such as databases or APIs, and we can see that through the distributed tracing. You may also have a lot of our customers, probably about 60% of the performance issues are DB related. So that could be, too many queries in a transaction or a page, maybe poorly written JDBC, maybe you're missing an index off a table or something, or you need to reorganize tables or reorganize keys. That could all come up, but FusionReactor should highlight that for you. Then you've got memory problems, so potentially you are allocating too much memory on a transaction. That can occur, and even if maybe the transaction runs quickly, but you're allocating a ton of memory, that can be a problem. And then you may also have a memory leak, and I can show you some of the tools that will help you analyze that. And then, this production error where you've got the elusive corner case, and that could be a number of different issues, but we'll take a look at a few things there, and I'll show you the event snapshots and the debugging capability.
Okay, cool. Well, let's have a look at that. I certainly say most of the ones we see where we're helping clients, it's slow queries. Occasionally it's API calls that are slow. Sometimes it's badly written ColdFusion code. But
yeah,
I'd say the number one thing is database.
Yeah, very, very, very often it is database. Okay, so right, I've got FusionReactor here for those people who've not seen it before. FusionReactor is a hybrid. So what that means is FusionReactor is you've got an on-premise user interface, and we've also got a cloud-based user interface. So if I take one of my servers here, this information that you're seeing here, this is live. This is essentially the same information that you're seeing here.
So let's just go back to that, David, because not everyone, some people are listening in their car or wherever they listen to podcasts. So we've got some graphs showing how much memory is used, server throughput, CPU, and then a bunch of other statistics that be memory heap, thread state, and so on. So you can see them changing in real time in this screen. Yeah.
And I think the interest, or the point to note is that, like I said right at the start, we're measuring telemetry. So we're measuring metrics, and what we're showing here is that we've got access. If I click on the graphs here, these are a bunch of different metrics which I can visualize. So you see there's quite a lot of metrics available here, and we've got many more that we don't visualize through here, but you can access in different ways. And with the on-premise UI, this is sort of fairly rigid. These are the main things. So the main things are web requests that people want to see. It's JDBC activity, and it's the two main resources, which is memory and CPU. So that's essentially, what you see here. And if we just if I just drop into requests,
and then the screen we saw earlier listed all the servers you're monitoring, so you can monitor multiple servers. And it seems you've got a collection of badly behaved apps for demo purposes. It's like a zoo of dangerous ColdFusion animals, so to speak. Yeah. And so we can see them gobbling up memory or running out of CPU or whatever they're doing.
Right. Yeah. So I've actually got a number. I've got CF 2018. I've got some other servers running CF 21. I've got some Java. I've got a Spring Boot application here. I've got a Struts application. So I've got a bunch of different sort of tech running.
Can you, for those who are watching this on YouTube, can you bump up the font size so we can actually read?
Sure. Yeah.
Read what the wonderful things you're showing. It's a bit like you're the zookeeper here.
Yeah.
Keeping an eye on these dangerous ColdFusion apps in their cages.
Dangerous animals. It's dangerous.
Yes. But okay, after using FusionReactor, your ColdFusion app will no longer be a dangerous animal. It will be a nice pet that will perform well.
It'll be a tamed hamster.
Yes.
After you put FusionReactor on there. Okay, so what we're looking at here, I'm just showing here some transaction details. So everything every transaction that gets run, or every web request that gets run, we get transaction details, which show the URL where that was called. We can see the status codes, whether it returned a 200 or a 500 or a 404 or whatever it was.
How do you manage to capture 500s? That's where the IIS or whatever you're using for your web server gave up, right?
Yeah, there's various different ways to do it. I mean, you may have a handler that you've got built in which case there's a call out to capture the information for Reactor. Or if you don't have a handler, we'll detect it. We get that out of the JVM. So a little bit about how Reactor works. Reactor is a it's a Java agent, and it uses something called AOP, aspect-oriented programming. And what it's doing is it's embedding itself, it's injecting itself into bytecode at runtime. So that's how we instrument. So we're altering bytecode at runtime to get this instrumentation data. That's how all sort of all the grown-up monitors, that's more or less how they all do it. That is the way to do it. So obviously it's tricky. I mean, if you get this wrong and you don't, you get your point cuts wrong, then obviously you can do a lot of damage. But we're obviously, with so many production servers, we would know very, very quickly if we'd done something wrong. So
the good news is this isn't a high level thing. It goes right into the details of the application and can even find stuff where you don't even get an error message.
Right, absolutely. Yeah. And you can see here, I was just going to say, we've got some queries, so we can see we've got JDBC stuff going on. So this is a very simple select, but you get the idea. So you can see how much time.
Now this is the detail screen. I'm assuming you have like a summary screen where you can see all the pages run. Or all the tasks run, and then you could pick the one to drill down into the detail based on it being slow or whatever, or the result code it was giving.
Yeah, absolutely. Yeah, we've got a number of different pages to show sort of collections of long-running transaction database problems, and what we also do is I'll just sort of try and describe what you're looking at here. Is basically here you've got a visual where you can see the hotspots in this particular transaction. So I can see this was a Struts one. So Struts is a Java framework, but I can see that I spent around about half of my time in the Struts transaction of the total time. So it was like 61 milliseconds this ran for. 33 milliseconds was spent in this Struts transaction, and 26 milliseconds was spent, so just over a third was spent in this JDBC request. So we sort of give you all the details. But what I was going to do, so thinking about performance, one of the first things that I wanted to sort of take a look at was performance. And I'm going to show you, I've got some ColdFusion examples here. So these, I've got a number of servers running. I've got a number of applications which are running. And this is our cloud UI. And I can see here not just individual transactions, but I get a complete holistic view of my application. And if that application was running across multiple servers, I'd be able to see the total performance of the app. So not just individual server instances, but I get a complete holistic view. And that's important because usually when you're analyzing an application, you really want to know what's it like, what's the performance of it for everybody. I mean, you might have, you might have some setup where, I don't know, you've got half a dozen servers set up in a cluster, and you're just taking transactions across all those different servers, but it's all running the same app. And for that reason, sure, you want to look at the individual server instances, but what you also need to see is sort of how's this application performing, and this is what you're seeing here. And I can see, if I click on slowest, I see I've got two sort of ColdFusion pages here which are slow. This top one, this products.cfm. This one seems really slow, and some pages run fine, so sort of sub-seconds. I can see 575 milliseconds, but some of them are crazy, so crazy slow, almost 50 seconds. I can see that in the view here. So if I just set the minimum duration, let's just set it to 10 seconds, and I can see I've got a number of I'm looking at a number of pages here that ran 37, 36 seconds, and I'm going to drill into one of those. Now, when I look at this, if I look at the trace of this doesn't tell me very much. I'm looking at this. I can see I've got a CF-HTTP call. I'm doing a little bit of database work, but the database ran very quickly. It was like 1 millisecond. The CF-HTTP, I had an HTTP GET that ran in 94 milliseconds, but the whole thing took 37.69 seconds. So why is that? And how I can find that out is through the profiler. Now, when I click on the profiler here, what just happened there was FusionReactor brought up the complete profile for this transaction. And I can see here, looking at this, that over 99% of my time was actually spent in errors.cfc. So this particular page actually normally it runs pretty quick, but something that I'm doing here in this errors.cfc is actually causing it a problem. And what I can do from there is I can actually drill into the code. So for people who are listening, if you're listening at home or listening in your car or wherever, that profile is basically it's live. I can click on individual classes and individual methods, and FusionReactor will instantly decompile the code and highlight where in the code it was running. So what I'm looking at now is I can see the reason actually why this thing takes so long is because I'm doing a dump. I'm running through various different directories here, capturing, I'm recursing through directories, and I'm capturing error information, and I'm dumping that out to a file. And this is taking a long time in this particular case. So actually the problem
now,
here,
just to be clear, is this the actual ColdFusion code, or is this the Java bytecode decompiled?
This is actually Lucy in this particular case, but this is decompiled it. So this is what
it's decompiled. Okay, because I'm just wondering, because what I'm reading is it's got variable 4, variable 6, variable 8.
Yeah.
Those don't look like good variable names.
No, it's not good variable names, but basically, why do we do this? So why do we do it? Very simple. If you're trying to investigate something as a developer, the faster you can get inside the code, the better. That's basically what this boils down to. So This capability, this is unique to FusionReactor, being able to decompile the code on the fly and present that code to you. And what we can also do, I didn't do it in this case, but you can, if I provide the, I can tell FusionReactor where my code is located. So I can basically point it at my repository, my local repository. And if you do that, FusionReactor will actually go and get your code and render it.
Cool. So it works either way. If you have a production server and it has only compiled code on it, it can decompile it. You can see something. But if you set it up a bit smarter, it can show you your actual code and lines of code that are slowing it up.
Yeah. And that's
genius.
important. Yeah, not everybody is as familiar with the Java, but it's actually, when you look at it in this particular case, it's pretty obvious. It's it's running through, it's basically recursing through a directory list and capturing error information, and it's writing it to a file, and that's what's taking it so long.
Yeah.
So
this isn't that uncommon. We had an engagement a year or so ago. The app ran fine, except when it threw an error, and their error handler was dog shit code. Not sorry to be impolite there, but I mean, they were doing so much in their error handler. We just made it a really simple error handler, and the whole problem went away.
Yeah, well, and this is what we're demonstrating here, and this is not an uncommon problem. I mean, this happens, right? You've had it yourself. This was calling an error handler. So errors.cfc, when it had an error, the code itself runs pretty quickly. I mean, the regular, we saw before, when it normally runs, it's sub-second, but when it's got an error, that's when it goes bad. And you can see that very clearly here. Okay, so that's
I think the other approach we took was to kind of do all that. If you really had to do all that heavyweight processing, do it in a scheduled task separate. So it would pick up new errors and grab out all that stuff that takes, 30 seconds to grab, but it isn't slowing up the actual page.
Right, exactly.
So, anyway,
there are different techniques to doing that. So, okay, so let's take a look at this other one. So we've got another performance problem here. I need to change.
This is a baby problem. This only takes a second to run.
This is a baby problem, but this is a problem all the same. So I've got some transactions here. They're taking just over a second, and this is all. A lot of this, when some people look at it, they might say, "Oh, a second, that's nothing." And other people,
but it's on their shopping cart checkout page by looks of it.
Right? Yeah. So
it's probably costing them big money because some of the people abandon.
Yeah, it could be, but different things are different to different people. And somebody might say, okay, 1 second is totally unacceptable. Other people might say, oh, a second, that's fine. But anyway,
if you're running an e-commerce store, you're comparing yourself to someone like Amazon, where they have things really snappy usually.
Yeah.
I think their goal is 200 milliseconds, I want to say, for page rendering. I may be wrong on that.
Yeah, Amazon did a lot of work in that area to identify, if it takes another 500 milliseconds, how much does that cost them? And
it costs them millions of dollars.
It's millions of dollars. It's millions.
Right.
I mean,
so you should pay the $19 to $99 a month to get FusionReactor to save yourself millions.
Okay, so let's take a quick look at this one, and I can see here again. I got some CF/HTTP post. It's calling this order process, but I've got no visibility in this. So this one, I had a duration of about a second. But let's take a look, and this is an example here of what we're doing with distributed tracing. So this is all part of this new capability. I can see I've got this trace ID, and I'm going to copy that. I'm just copying it, but I'm going to click on it as well. So when I click on it, what happens is we're now basically taking that trace ID. And this, you asked before, what is a trace? This is a trace. So I can see here that I've got this trace.
Can you make the font a bit bigger on that?
Can I make the font a little bit?
I mean, I have a really big screen here, and anyone on YouTube probably doesn't. So we can see all the different things being run inside this ColdFusion page.
Right. So there's more to this. So the lines that you see here, these are what are called spans. So a trace is made up out of spans, and I can see I'd got my CF storefront, I had the CF HTTP call, but then I called out into this order processor. And actually, this order processor, then it generated an invoice, and it called out into a database. I've got some inserts and some selects. And then finally, that went into, it's called out to Kafka. So I've got a call to a Kafka bus. And then I can see here, I've got that then called out to the shipping processor. And the shipping processor is actually in Node. So I can see for, this whole transaction here unfolding, and I can see all the components of it. We've never had this in FusionReactor before. So this is not inside CF. Yeah, this is
that's amazing. So you've got some bits in CF, and then you've got other bits in Node.
I've got some bits in CF. I've got some bits in Java. I've got some external database that we're instrumenting.
Is the length of these bars show how slow that process was? And it shows some are running in parallel and some run sequentially. Is that right?
Because and you could also, if you think about it, you may have some asynchronous call. I mean, very often, when you write stuff in CF, it's synchronous. But, if you've got an asynchronous call, how's that going to work? And that's what we're also able to support. This whole distributed trace, what we do is we pull, even if it's asynchronous, we pull all the spans together, and we'll visualize it for you so that you see the complete transaction end to end. And I can also, for this, when I go and look at this thing, if I open one of these up, logs for this span. So I can make.
So it ties into the logs just for that.
So basically, these are the logs that were related to that. So I've just linked that now directly. And I can jump back. If I click on the trace, that's going to take me back into the trace. So again, a big part of what we've done is this linkage. And what I'd also like to show you real quick is, if I go into the Explore screen, we've not got this all built into, we've not linked it all completely, but we will do. But this was the trace ID that we got before. So this was the trace that we were just looking at. Look at this. If I click on this node graph, this is visualizing now the complete transaction. So I can see that I've got my ColdFusion, my storefront. It was doing a CF HTTP call. That was an HTTP post. It went into this order processor that called into here to process the order. This called my database. So I've got some selects and some inserts going off here. And then finally, that went into the order processor, which was Kafka. Kafka called out to from the order processor to the shipping processor, and the shipping processor did some screen rendering, and this is in Node. So these last two components.
So for those not watching the video, this is like a map of all the processes together with performance numbers that you can click into and see how it's doing, and it shows all the stuff running sequentially or in parallel. It's I haven't seen this kind of view before. It's really cool.
Yeah, no, this is all new. This is all part of FusionReactor 9. But the important thing here with distributed tracing is you've got the end-to-end breakdown. So before, you might just see, you've got your ColdFusion page, but if you've got call outs, you're calling some service, or maybe, calling something in Java, or, calling a database or something. It was sort of still, you got the total amount of time, but it was still a bit of a black box. And that's what we've addressed here. And of course, being able to visualize that is phenomenal. Because when you're looking at it and you can see the node graph here, it's very easy to follow. And that you've got that combined with the trace view, so that you can see each individual span within that trace. And within here, you've also got, like I showed you before, the links to the logs. So got everything combined, everything together, and you can visualize that. So it's a big sort of, it was a big deal for us being able to provide that capability. Any questions about that?
No, my mind is blown, David.
Your mind is blown. Okay, so let's blow it some more. So another one of the things that we talked about was being able to analyze databases. And if I go into here, and this is also in the cloud here, I can see, this is my database view. So I can see I've got a bunch of databases here. I can see throughput, and this is per application. So I can break this down and say, okay, just show me my Spring shop. And if I do that, then it'll just focus on Spring.
So you can see the effect of each application in the database.
Absolutely. You can see
it somehow knows the queries that a particular application is running. Because usually when I've looked at database performance, you see all the queries from all the applications all mingled together.
Yeah, no, well, you can mingle them if you want, but you can also individual break them down. And of course, what you can also do, you can look, if I go back into my applications view, I can also drill into individual transactions. But let's just go back into the on-prem. Here, I see in this view, you mentioned before that it was useful to get sort of collections of information, and this is one such collection. These are all our JDBC requests. So
and then you can sort them by the ones that you use the most CPU or the most memory or whatever you're looking for.
Yeah. So you can sort them. Basically, I can say, show me the slowest.
Yeah.
I want to see these are all the slow ones, and these are derived because they're all select, or there's a lot of them sleep 8 seconds, but we've got other ones in there as well. So you can see those ones. What is also really interesting, transactions by memory. So I mentioned before, one of the issues is could be memory related, and I can see here, some of this guy up here took, a lot of time. 72 megabytes was basically used up on that particular select statement. But sometimes you may have something that is, it runs really quick, but it consumes a lot of memory. And you can also see that as well for a transaction. So going back into the transactions view, if I go here and look at request by memory, this one is actually, this top one here, we're using almost 7 gig of.
It's a bit of a hungry process there.
This is a bit of, but there's a reason for that. And if I drill into this one, we can take a look at it. And this one is actually building a database. So this one ran for 23 seconds. But I've got a bunch of create table statements here, and you can see all the individual SQL statements, and then I've got a load of inserts. So and I can see for every single one what the total time was, what the time spent on DB was, and how many rows were returned. That's some, another great feature, because you might be selecting some data from a table. And when you wrote that application, you didn't have that much data. So you just did
Yeah.
select star from wherever, you didn't really qualify it. And,
Yes.
for the first few years, this all ran great. And then across time, it gets slower and slower and slower. And
Right.
one day you wake up, you think, God, why is this thing so slow now? And the reason is data. And very often, that's linked to databases and, poorly written queries.
And a lack of an archiving policy where you get old transactions moved out if you don't need them in the main app.
Right, yeah. Okay, so we've taken a look at the database, sort of memory issues. I can drill into here, I can get a picture of my current memory. So this is live. These are all the different memory spaces. I can also go back and look at that across the last hour. I can also see that in here. So in the cloud view, if I look at, if I take Java memory, I've got all the same information. I can look at that again live for the last 30 minutes or hour or any time,
Wow. And all the data's saved off into the cloud, so you can keep days of data there, or what's the restriction?
We can keep, so right now, today we can keep up to 90 days worth of data, but we're checking that. So we're going to actually offer, the next phase will be 180 days, so a half a year, and very likely we're going to go up to a year. Yeah,
because sometimes these you can see trends over time, so it can be useful to have older data. I can't see it in this view, but some of the other graphs you showed, you can see the memory creeping up, and you can see the garbage collections being done in the JVM.
Right,
it goes down, and
here you've got garbage collection time. I can show you that in here as well. If we go and look at the GC. So this is a
garbage collector, GC.
So this is the garbage collector. This is a very typical sort of graph. You can see the GCs run regularly, but sometimes
which is good.
Sometimes that's good. But sometimes, we've talked to customers and they say, oh, my application's crashing. And then when you start looking at it, you realize that it's just running out of heap. And they've reconfigured, they've sort of tuned the GC, but tuned it to kick in too late. And then, they get spikes, they're running out of heap. And then the GC's cutting in right at the last moment. And
then it takes a long time to clean up the memory.
And when the GC runs, it's a stop the world moment. So, GC runs, everything else stops. And then they're saying, well, my application freezes. Too true. That's what it's going to do, because the GC, the garbage collector's killing itself, trying to free up memory. And it's because you've tweaked it.
I mean, for people listening, what I'd say is that, the way Java virtual machines run, when they finish with a piece of memory, they don't automatically clean it up. This garbage collector comes in periodically to clean it up. And it's almost like imagine you're in an old style home office and you've got lots of pieces of paper, and then you're throwing them away, and you've got this big pile of garbage. And what I think David was saying is, if you clean it up regularly, your office stays tidy and everything works good. But if you wait until the last moment where the garbage is up to the ceiling, then it takes a few seconds to clean up all that old memory that's no longer used.
Absolutely.
So that's one of the things we see. And then the other thing, sometimes the garbage collector doesn't reclaim all the used memory. There's a memory leak and it can't get back everything. And over time, it goes up and up, and then eventually you run out. So.
So if you've got that scenario, then we've got a tool for that as well. And this is the heap histogram, or the memory profiler, as I sort of call it. And what I can see here is this is the heap in real time. So again, for those folks sort of listening from home, what I'm seeing here is a screen which is showing me every single class which has been instantiated on the heap, together with how many objects and how much memory has actually been allocated.
Can you bump the font size up there for the people who are watching on YouTube?
Yeah, I can try.
So we've got an object, a class at the top that's gobbling up nearly a gig of is that a meg or a gig? It's 26% of the memory.
Yeah, that's actually, it's 285,000 bytes. No, 200. Yeah, no.
So it's a quarter of a gig.
Yeah, quarter of a gig. Yeah.
Yeah.
So yeah, but that's char, that's character. That's probably not too bad. But you might have something. I've got a hash map here, which seems hungry. But what you would do in this particular scenario is you would take a snapshot. And what we recommend is that you take a snapshot when your application's in clean state. So when it's just started, or when you know it's good. And then you take a snapshot when you think you've got an anomaly. So when you believe you've got with memory. And then what you can do in here, I can take those 2 points in time and I can do a diff. And the diff compares everything at that point in time. So I can see all the different classes. I can see how many objects were instantiated, and I can see the size of that. So I can get a really in-depth picture here of exactly, how memory is being used. And this is a sampling profiler. So what that means is you're actually the impact of it is very, very low. So FusionReactor is still around about 1% impact. Obviously, if you'll remember from high school physics classes, if you measure something, you have an effect on it. And obviously, as a monitor, you've got an effect on the application that you're monitoring, but that impact is very, very low. So
yeah, I mean, that's very important that it only has, because otherwise, if the monitor uses up a lot of resources, the monitor can slow down the app. But if I'm understanding correctly, you have some really cleverly written fast code that grabs the telemetry and the traces and everything, and then it's all sent off to a different server out in the cloud where it does all these clever graphs and reports and what have you.
Well, it's both. We've got it. You can have it on-prem, and you've got all that capability. And if you've got cloud, then we're capturing it. We're actually compressing it, and about every minute,
and encrypting it.
And encrypting it, of course. Yeah, it's all sent securely in a secure channel up to the cloud, and then it's encrypted at rest as well. So all your data is safe. And yeah, we're sending that information compressed. Actually, the packets are pretty small. Actually, I think they're about it's about 11 megabytes in a packet. I think, which is it's about 11K in a packet. It's even smaller. They're really tiny. The packets that get sent. So. Yeah.
Did you have one more important feature you wanted to show from FusionReactor 9 before we talk about the future?
Actually, yes. One thing that I did want to show is just wanted to show you the debugger. So I've got a little bit of coding, and what this does, it's got a random number generator. I need to run it a few times.
Right.
There you go, got it. So I just did a divide by 0, and I've got a random number generator between 0 and 3, and I caught it. So let's take a quick look at that. So I can see here, this was the error that I caught, and when I drill into that, I can see a few different things. I can see this is the stack trace here, and I can also see the event snapshot. Now, the event snapshot, this is this automatic error detection. And I can see this is highlighting the line in the code where the error occurred. And obviously, there's a very simple example here. but I can also see my variables. So when I click into here, I can see that y was 0. So that's why this error occurred. But I can also see all the variable scope. So I can see everything, the whole context of.
So this is like doing a dump in your code, but without having to write that.
Yeah, this is you know, at the crime scene. This is the CSI. This is having the camera at the point that the error occurred. So it's taking a picture of the whole context of the issue. And what I can also do is, if I go into my error details, and you remember before I said you can tell FusionReactor where your code is. That's exactly what I did here. So I told it where my repository was. So you can see this is the file name to it here. And I can set a breakpoint. So when I do that, and then I run that again.
So you're setting breakpoints near where you think the problem might be happening. And this is a toy example. In the real case, you know, the error might be far more complicated. But.
It may be, it may be. Yeah. But if I run that, you can see that now spinning. It didn't complete, and when I go back into the debugger, this is the thread. So I've intercepted that thread, and
before it had the error.
Before it had the error, and I've
so now you can look at the variables.
So I can
you single step?
Yeah, so if I click on the debug icon, now I'm inside a debugger, inside FusionReactor, inside production.
Wow.
So, and this is a full blow debugger. So I can step into, step out, step over. You can see you've got the different commands up at the top. I've got all my stack frames here. I've got access to all my scope variables. So I can see that in this case, it's captured it y is equal to 2. So if I change that,
you can change the variables while it's running.
Because this is a debugger. Right. So if I change, and you can see on the right-hand side, I've got a watch set up, just like a regular debugger. If I change that to 0, you see the watch changed.
Yeah.
So that variable now is 0. So if I resume this now, what happened?
Now the page will...
the elusive demo effect. It didn't normally. That should have come back. I don't know why that was like that. But
no worries.
Oh, no worries. Okay, there it is. Divide by 0. Yeah. It normally would have changed. I think what I've got actually. I think what's happening here, I just noticed that before. I've got this running in the background, and it's picking up that URL and it's executing it. And what's important to point out here is that debugger is on a single thread. So you can configure it to fire on multiple. But of course, if you think about it, if you had something if you stopped every thread, your whole application could stop. So by default, we only do it on a single thread. But I've actually I've got other threads running in the background, so it was just firing it. So it just picked, it was just the look of the draw there. It just fired it, and you can see.
And this is a feature that's been in FusionReactor for a few versions.
That's been in since 6. So that's been in a long time.
But very handy to have.
Sort of real quick, just let's take a look at some of the new stuff. Other than what I've shown you so far. So we've got the logging capability. So this is going. So I've got my logging dashboard here. So I can basically see. Let's just click on FusionReactor logs. So these are all my logs that I'm pulling out of that are being captured by FusionReactor. And I can look at various different jobs. So, I've got my storefront here. If I select that, then it'll just show me, logs from my storefront. And you can see I'm sort of drilling, I'm looking at those. If I change that to all, and then I say, okay, I want to look at the last hour of logs, then it will go and it will render. These are all the different logs that are being captured. So I can see this is throughput. that you're looking at
Mm-hmm.
the top.
Mm-hmm.
And down below, these are the actual logs themselves. And not all these logs have got, they've not all got connected traces. But if they did, you'd also be able to jump from one of these log files into a trace. Obviously, some of these logs, you know, they're not linked to a specific trace. But if they were, then, you know, we'd be able to sort of join the dots there. So you've got logging. I can also, if I go back into my dashboard, I can see here that, come on, log dashboard. I can also look at errors. So if I click on the log errors, again, this is pulling up, but I can filter these. So if I said, okay, show me everything with an exception. So these are all the exceptions I've been throwing. And again, the logs are automatically filtered down at the bottom. So these are only logs which were related to some exception.
Yeah, I mean, that's the problem with looking at raw log files, that it's all mixed up together and it's hard to find.
Right,
So
but the beauty of this is that you can filter all that stuff. So you know, we can also, as well as doing that, if I use my log events here, I can basically I can add filters into this. So what we've introduced now is the ability to filter these. So here I can see I've got various different, I've got my application name or file name or host or instance or job. So if I take job and then I say, okay, just show me my CF storefront 1 and actually just show me errors. So I don't know whether I'm going to have any in here. Looks like I do, but these are just CF storefront 1 errors. So all the you know, all the log files shown here, and I've reduced I've increased the font size so that people can see. But normally it's pretty large at the moment. But normally you've got, you know, more real estate to be able to actually see the logs, and these go very, very quickly. That you can render this information. Let me just show some of the other dashboard capability that we've got. So some of the other sort of new stuff. Show you request performance. So here you can see these are transactions that you're seeing here. And I can see that based on average duration, so how long those transactions are taking. Also for the different traces, what the throughput is, what the request status was. So I could take something here, and if you notice with the mouse, when I mouse over this is giving me all the telemetry. But if I click on one of the things, I've got some options here. I can add a notation. So this is another new capability. Let's say you've got situation, you can annotate it. So if I annotate that, I'm just going to say, I don't know, high load or something due to whatever. And I'm going to add a tag for this. Let's say, you know, this is, I don't know, lots of users. I don't know, but whatever it is. And then I've tagged that, and you can see that's now highlighted, and that annotation, it will appear now everywhere. So what you can do by doing that, you can use that to correlate right across your application to see, you know, some potential incident that was happening. And we're gonna add these annotations. We're actually just working on that at the moment. We're going to add these automatically. So you might have, you know, a server crash or some other event, and we'll just automatically annotate it for you. But what I can also do is, I'll just do that again. Just sort of right mouse click there. If I click on show events, then automatically for that particular that issue that I've got there, it will show me all the correlated log events for it. So it just does that automatically. You know, we've just linked all that so that you can, you know, if you had some spike, you want to say, okay, well, show me what's inside the logs. And rather than, what you said before, that you're searching through the logs and trying to correlate it, we've done that automatically for you. So here I'm seeing all the correlated logs. So that's that. I can also see things like resource usage. So here, this is CPU memory utilized, very, very visual, very rich graphs that we've got here. This is showing all resource usage for all the different jobs that I've got running. But of course, I can break these down. So if I said, just show me, I don't know, show me what's happening on storefront 1, then it will just take that, and in that particular case, there was no data on that one, but it will, let's take a different one. Actually, let's take that one. Yeah, so that one, we do have data for that one, and then you can just basically just drill into a specific application or a specific job. So that's some of the FusionReactor related stuff. Let me just show you some of the, what's coming in the future.
When you said job there, does that mean a page running or a scheduled task?
That particular thing was actually, that was an instance. So job in that particular case that's referring to an instance. So that was our CFers instance in that particular case. Let's show you some of the stuff that's coming up. So I mentioned before this sort of observability platform, and if I go and look at this, let's just take the last hour here. So this is our node exporter. So if I'm just going to make this a little bit smaller, just to give the effect of what you can see here. And as I scroll down here, and this is hardware, right? So this is not application telemetry. This is hardware telemetry, where my application, one part of my application is running. But I can see here, I can look into CPU memory, I can look into system processes, I can look into disk utilization. So I'm now looking at disk IO ops. And there's tons of information here. I can see read write on the disk that's going off. I can see network traffic. So I can see how many packets are being sent. I can see whether I've had any network errors. So that this is telemetry. We've never had this in FusionReactor before. But this is all, all available now, and more of this stuff is going to be coming.
So it's almost like you can be physically on the box, but these days so many quotes boxes are running in the cloud, you couldn't physically get there anymore. Yeah,
but you will be able to, you're definitely going to be able to have that. This is an exporter for MySQL. So this is a MySQL database. I'm not using this in any of my applications, but I've got the database available in my infrastructure, and I'm just instrumenting it. So I can see, what the thread cache was. I can see how long it's been up. So this has been up for almost an hour. I can see how many operations are being performed. I've got a ton of telemetry here that, normally we would never have this available. But it's all, all fair game now with this new architecture.
Cool.
So yeah, so that's some of the new stuff. What's coming up in the future? Well, that's part of it. Another thing that's coming up that I mentioned before is the machine learning. And what we've been doing here is we've been working on using various different machine learning algorithms, and we've been using a couple of different ones. We've got from Facebook, it's called Profit. We've been using that, and another one called K-means for clustering. But what you can see here is this is analyzing CPU information. So I can see across the last 12 hours, it looks like I didn't trigger any anomaly flags, and this is all live data. Sure, what's coming out here. But if I increase that up to 24 hours, let's take a look. It's analyzing this in real time. And now you see across 24 hours, now it started finding anomalies. And you can see the spikes in the anomaly flags. These are basically where the machine learning algorithm has said, hey, here, something's wrong. And if I open that up to 2 days, so I'll start looking a little bit further. Interestingly, the number of anomalies dropped. So when it took, the more data it takes, the better it gets. And of course, I mean, this is, for now, this is just experimental for us. But, the power of this is going to be when we join all the dots, so that you can say, okay, well, I'm looking at my CPU in combination with my memory, in combination with what's going on the database, in combination with transaction throughput, and based on all the different pieces of information, I can actually determine that, hey, I've got a problem here. And it's that ability to join the dots sort of right across your application architecture. That's what's going to, that's where you need something like machine learning to, to enable you to really analyze the data and spot potential issues. So, yeah.
So at this stage, you've got the machine learning helping you spot areas where problems are happening that you might not have noticed.
Right.
And then maybe in the future, it does a bit more activity to.
Well, I like I said, right at the start, that this is going to go in phases. So I think phase one is going to be alerts. And, and we've started using this ourselves on our own platform. And it's amazing. It's amazing what it can spot, where you'd think, why is that a problem? But then it spots something. When you start digging into it, you go, wow, yeah, that is a problem. But you would have never seen it just because you didn't join the dots, or you didn't think that, oh, actually, that's that particular thing, that's an issue. So it's really,
because maybe it's a lower level thing before it becomes crazy and crashes the server. It's a precursor to something happening.
Right. So so that's sort of the cloud. So we've took a look. So just going back onto the slide. So with the logs here, I don't know how we're doing for time. We've probably blown our time frame. But I just wanted to say here that, Reactor can now capture logs. You can filter them very, very quickly. You can visualize them. You can put them in graphs. It will join the dots for you. Obviously, the advantage is you can diagnose issues faster. This is sort of a little diagram of how it works. So I've just shown this with CF21. You've got this logging agent, where you can use different open source components here. So we can scrape any logs. It doesn't have to be a ColdFusion log. You may have some other application logs, or the IIS logs, whatever it is, we can capture the logs. And then we're ingesting those, and we're storing them and making them available in the cloud. So you may have some other, we used to use Papertrail, but we've stopped doing it now. It was really expensive, and it was like we were spending, I don't know, $300-400 for 16 gig of logs being captured. And then that it wasn't that much. It was a lot of money, but it wasn't that many logs that it was actually capturing. So if you've got a separate logging application, really think about moving that onto Reactor. and basically getting the benefit of having everything in a single pane of glass. And then the last
new things coming next year.
New things coming soon. So I showed you some of this stuff. So we've got this infrastructure monitoring where I showed you Node, but we're going to also have Kubernetes, Kafka, AWS dashboards, and we're going to have lots and lots of dashboards. So you saw, I think when I was showing you, there was a lot of different dashboards. I didn't go and show them all, obviously, but the concept is that we're going to render these automatically. So we're going to detect what you've got in your architecture, and then we're going to provide the dashboards to you automatically, so that it will automatically render your information. We are embracing OTel, this open telemetry standard, so that we can provide fully distributed tracing across different languages and technologies. So we saw that earlier. We've got ColdFusion, calling Java, calling an external database, calling Kafka, calling some more Java, and then calling to Node to do some client rendering. All that was visible, all basically showed in the distributed trace. And then finally, this machine learning stuff, and this is the future. And that's why we're sort of looking at that now, and we're putting focus into that, because that capability, that's going to be a game changer. Just having the data and being able to analyze it and then make recommendations or set alerts. And in the future, who knows, maybe actually automatically fixing your applications, using the power of machine learning. It's funny, when we started with FusionReactor, one of the first concepts we came up with, we said the big green button. And the big green button was what we envisaged pushing, and that spotted the error and fixed it for you. And, we've sort of, we're 17 years on now, but that big green button is very tangible, and, we're almost there now.
Wow.
So
before you know it, the machine learning will be writing the code.
AI already writes code.
Mm-hmm.
You need to take a look at that. If you imagine, Google's got access to the whole of Git, and
that's Microsoft, not Google.
Microsoft
owns GitHub.
Yeah, but
and they have Copilot.
Google's indexing everything.
Oh, that too.
Yeah. So
good point.
They've already got engines which you can write it a spec in English language, and it will write code for it automatically.
Wow.
It's phenomenal, and it's analyzing all the different algorithms that people are using, and basically it's got it all figured out. So that's reality. What will happen in 5 years? Who knows? But I think we've lived through interesting times. When I started my degree, my major was artificial intelligence, and a lot of the concepts, a lot of it's all the same stuff, but it just wasn't possible, back in the 80s, because we have the compute power and we didn't have the access to the data. And that's all gone now. Now we've got, unlimited compute power, and we've got, pretty much unlimited data. The maths behind the AI, it's all the same, same stuff.
Right.
Yeah. So to summarize, Reactor, it'll find and fix errors in your code up to 5 times faster, lets you know when, where, and why issues occur. It's very low overhead. We've got this full observability platform, so it's not just ColdFusion, it's going to be other languages. We've got logs, we've got infrastructure, other integrations. You can use it in development and production environments. It's dead simple to install, literally minutes. got a 14-day trial. Licensing, you can reserve servers or hosts, and we've also got on-demand pricing, so you can just pay essentially for what you use, and pricing runs from $19 for a developer license per month up to $99 per server host per month.
What a deal.
What a deal. Yeah, what a deal. It's amazing. For the time that you save. You imagine if you had one issue a month that took you 2 days and you've got a couple of engineers working on it, how much does that cost?
Right.
That's thousands of dollars.
Yeah. And the cost to the organization of the site being slow or crashing,
right,
you could be losing way more than that.
There's the knock-on costs. There's the, what effect is that having on my reputation as a company? Because customers are experiencing pain. All that cost that's difficult to quantify. But if you just look at it from a developer perspective, what the developer costs, and then say, okay, well, we're going to, rather than spending hours or days, you're going to spend minutes or, maybe an hour to find it, but you will find it. It finds everything. And that's where you save the money. So
great. Well, everyone listening, if you haven't tried out FusionReactor recently, it's worth checking out FusionReactor 9, free trial to try it out. And we use it at TerraTech. It helps pinpoint problems with customer sites. So I think it's worth the investment. But there you go.
There you go. Yeah.
Now, I noticed you were pretty big at CF Summit in Las Vegas. You had a nice
we were
talk and a response.
Yeah.
Right.
Yeah.
Are you going to any other conferences in the next year or so?
Well, we'll certainly, we plan to go to ColdFusion Summit again next year, and I'm sure that we'll be platinum sponsors again. And it's just been announced today that CF Camp is coming. CF Camp is back. And
yay, back in Europe, in Munich Airport, in Germany.
Munich Airport. It's just down the road for me. It's a couple of hours away. So we will be
that's June next year.
Yeah, June next year. So Munich in June is fabulous. The beer's cold, the cake is sweet, and Munich is a lot of fun.
Yeah, great. And for those who haven't been to CF Camp, they hold it at a hotel that's right at the Munich airport. So if you're elsewhere in Europe or even the States or India, you could fly there, and you don't have to travel around Munich if you don't want to. Obviously, you could stay on later if you want to enjoy the sights.
But you should. If you fly to Germany from the States and you fly into Munich, there's a lot to see.
Yes,
the countryside is beautiful around there. You've got the Alps are very, very close. Munich itself is a phenomenal city. Loads of culture, very international, very cosmopolitan. It's brilliant. So definitely recommend, spend some time in Munich or spend some time in southern Germany. It's fantastic. But
it's a great place in the summer. It's a little colder in the winter.
They get snow down there, for sure. It's it gets cold, but it's weird at the moment. I mean, it's November. I've never known a November like this. It's so mild. It's weird, actually. Normally it's very, very cold. I mean, very often in November we've got snow, but there's no sign of snow at the moment.
Wow, crazy.
Yeah, crazy.
Yes. If people want to find you online, David, what are the best ways to do that?
Yeah, so best way is if anybody wants to mail me, if they feel the urge, then get me at david@fusion-reactor.com, or you can email the sales team at sales@fusion-reactor.com. I'm on LinkedIn. If you need anything, just reach out. If you'd like a personalized demo of Reactor, if this wasn't enough for you, then if you sign up for a demo, I can also do a demo for you. Then you can ask questions.
Wow, very cool.
Yeah. We're
Excellent.
here. We're here for our customers. We are very customer focused business.
Wow, cool. Well, thank you so much for coming on the CF Alive podcast, David. Best of luck with the FusionReactor 9.
Yeah, and we've got FusionReactor 10 coming. I think you mentioned at the start, but that should be coming probably Q1 2023 with even more capabilities and lots more stuff.
Wow, I look forward to seeing it. Well, thanks for being on the show.
Thank you for having me. Yeah, it's been great. Hopefully I didn't talk too much, but yeah, it's been great. I always love showing the products, and yeah, it's all good. Thank you.
Get detailed show notes on today's episode in your free CF Alive Modern ColdFusion Guide at terratech.com. That is TERATECH.com. Viva la CF Alive Revolution!